Hello and welcome to today's lesson looking at calculating the wave speed of waves, which falls into the waves topic of GCSE Combined Science. So in today's lesson we're going to look and understand how to calculate wave speed for any wave. Now if we're successful and we learn in today's lesson, we can describe the process of wave speed, understand that waves have a finite speed and this is a consequence for the universe, and finally calculate the wave speed of a wave. And this falls into the following part of the AQA Combined Science Specification for Physics 6.6.1.2, the properties of waves. Now we can work out how fast a wave travels in a medium by carrying out the following calculation. Wave speed in meters per second is equal to frequency in hertz times by wavelength in meters. Now you've got to be able to recall and apply this equation for your examination. This equation shows how fast a wave transfers energy through the universe, or you also could consider it the distance travelled by each wave every second through a medium. Now all waves, whether they are mechanical, electromagnetic, transverse or longitudinal, have a finite speed. It takes time for energy to propagate from one place to another in our universe. Now in many waves such as light, this time is not perceivable to human senses, but it is present. Energy transfer is never instantaneous in our universe. Now this equation cannot be used to work out anything but the speed of a wave. So you can't use this equation to work out the speed of a human or a car or a plane. It can only be a wave. Now for this equation to work correctly, you must have the frequency of the wave in hertz and you must have the wavelength of the wave in meters. This means you may have to convert the units of the values you've been given in the question. Now this equation makes very much a lot of sense when you consider what frequency and wavelength are. Frequency is the number of waves passing a point every second, and wavelength is the length of one wave. Therefore, if you multiply the two values together, it gives you the distance travelled by a wave in 1 second, which will be the speed. Now, you can also think of it as the following. Frequency is 1 over time period, as we've looked at in the previous lesson, and wavelength is equal to distance. So wave speed, therefore, is 1 over time period times by distance. So it's distance over time period, and that links to us because we know speed is equal to distance over time from the forces topic. Now, the speed of all electromagnetic waves in our universe in a vacuum is 3.0 times 10 to the 8 meters per second. This is the fastest speed in the universe. Nothing can travel faster than this particular speed, and also note that all electromagnetic waves travel at the same speed. So a radio wave will travel the same speed as a light wave, which will travel the same speed as an X-ray, which will travel the same speed as a microwave. Now, electromagnetic waves will alter their frequency and their wavelength to give a speed of 3 times 10 to the 8 meters per second. So what this means is the higher the wavelength, the lower the frequency, to get the two numbers to times together to equal wave speed, and also the shorter the wavelength, the higher the frequency, to times together to equal 3.0 times 10 to the 8 meters per second. Now mechanical waves can travel at different wave speeds because mechanical waves involve the movement of particles. The particles are vibrating backwards and forwards in a mechanical wave. This means the energy travels slower than for electromagnetic waves, because mechanical wave speed depends upon the mass of the particles which are oscillating and the density of the materials, how easy they are to collide with each other and transfer the energy of the wave from one particle to another particle. Now generally, mechanical waves travel faster in solids than they do in fluids, in liquids and gases, because the particles are closer together, so when they oscillate they're more likely to collide with another particle and transfer that energy across. Now, we measure frequency in hertz, and hertz is simply the number of complete waves passing a point or produced every second. So for example, if we say a wave has a frequency of 20 hertz, this means it is producing 20 waves every second, or 20 waves passing a point every single second. So let's just summarise what we've learned in today's lesson. Electromagnetic waves all travel at the same speed. This is the fastest possible speed in the universe in a vacuum, since electromagnetic waves are massless and they do not involve the oscillation of particles. The speed of all electromagnetic waves in a vacuum is 3.0 times 10 to the 8 meters per second. Mechanical waves all travel at different speeds, since this depends on particle mass and density. Now, mechanical waves contain particles with mass, so travel slower than electromagnetic waves. Now, using the equation wave speed equals frequency times by wavelength, we can calculate a value for wave speed. So look at this particular example. You are given the wavelength of a wave to be 45 meters and the frequency of the same wave to be 20 hertz. So what is the wave speed of the wave? The first step you do is you write out the equation. Wave speed is equal to frequency times by wavelength. Now note our units. Is frequency in hertz? Yes it is. Is wavelength in meters? Yes it is. We don't need to do a conversion. We then substitute the values into the equation. 20 hertz times by 45 meters. You then carry out that particular sum and you get an answer of 900 meters per second. Remember to use the correct units when you do this and give the correct number of significant figures. Now in the question it's given both values to two significant figures, so your answer will be given to two significant figures. Another example here. You're told the wavelength of a wave is 24 millimeters and the frequency of the same wave is 31 kilohertz. So you write out your equation. Wave speed is equal to frequency times by wavelength. Now the next thing you do is you check your values. Now wavelength has been given in millimeters this time, so that must convert to meters. So it's 24 times 10 to the minus 3, the conversion from milli to normal meters. And then the frequency is given in kilohertz, 31 kilohertz. So you've got to convert kilohertz to hertz, so it's 31 times 10 to the 3. You carry out your sum and you get an answer of 744. That will go to two significant figures because in the question 24 and 31 are both two significant figures, so your answer is to two significant figures, 740 meters per second, and we give our correct unit to go along with our value. So if we've learnt in today's lesson, we should be able to remember that wave speed is equal to frequency times by wavelength, where wave speed is measured in meters per second, frequency is measured in hertz, and wavelength is measured in meters. You should be able to recall and apply this equation. So hopefully you can describe the process of wave speed, understand that waves have a finite speed and this has consequences for the universe, and you can finally calculate the wave speed for a wave. I hope you've enjoyed today's lesson looking at the wave speed of a wave, which forms part of the waves topic in GCSE Combined Science. Thank you and have a lovely day.